One second, yeah. Transport phenomena syllabus will be Unit 1 and Unit 2.
Okay.
In the Unit 2, we have only flow through narrow slit. And in the Unit 1, we have everything except Fourier's and fixed law.
So 4 years and fixed law are not going to be covered, right?
Not to be covered, we need to cover Newtonian and non-Newtonian fluids till Newtonian and non-Newtonian fluids.
So you mean in this your first quiz you only have the fluid mechanics part, not a heat transfer and mass transfer.
No, madam. Only transport phenomena.
No. So basically, one second. Can you see my screen, right? You can see
Yeah,
it?
I can see your screen, madam.
Yeah. Okay, if it's not visible, tell me.
Yes, it is visible, madam.
So, okay, let's start. So basically, transport phenomena is mix of three parts. This subjects what you learn is one is FM, one is heat transfer, and one is mass transfer. So fluid mechanics, what we learn from the fluid mechanics is basically momentum. You don't need to write anything. I'll share this as a form of PPT. And heat transfer will give you idea about energy. And this will give you. Do you have any, before moving ahead, I have one more question. Do you have anything that your professor told in your class? You have written anything, something for my reference?
Yeah, madam. I just wrote on flow through narrow slit.
Okay. Has he taken any examples or like anything like it?
No, madam. I'm not too familiar with that.
Okay. Okay, fine. Manage that. So transport phenomena is basic. This subject, what you're learning, is an advanced subject. It's a final year subject. This subject is mixed of all the three basic subjects which you probably learn in your second year or third year. So what you are considering is the flow through narrow slit.
Okay.
It comes under the fluid mechanics part. If you imagine what chemical engineers do, what basically chemical engineers do is we have some reactant, or we can, in more general terms, we can call it as raw material. And our aim is to convert this raw material into some part of product. This is the role of any chemical engineer, right? This is the overall idea which we have to do. We have given some raw material, we have to convert this into product. To convert this raw material into product, we need a process. In that process, what we do, we have to do a reactions also to convert it into a product. For that reaction, we have to transport this material from one place to another place. We have to store that material to the next place. Then for the reaction, we have to do reaction at a certain temperature, whatever temperature we needed. For that temperature, we need energy. We need to transport the material from A to B. How we transport? There are ways to transport. Either you will use pipe, either you will go through a trucks, or you will go to the railway. All this needs a momentum. What is basically momentum? Momentum is going from one place to another place. All these things require a momentum. That's why we need fluid mechanics. If we are taking your raw material through the pipe, you learn that there is Heisenberg equation, there is a turbulent flow, there is laminar flow. Whatever you learned in the fluid mechanics comes in this area. Then, to perform a reaction, you require energy, you require a temperature, you require a catalyst. Why catalyst is required? To attain that activation energy fast. There comes the role of energy. When you use catalyst, that and then mass transfer. Mass transfer is basically considered under the area of diffusion. So when you learn about phenomena, you have to learn all these three subjects individually, and in the transport phenomena, we combine all the three subjects and then we solve any situation. So for any balance, for to solve any transport phenomena problem, first you required a balance. So basic formula of balance is accumulation equals to in minus out plus consumption or generation. So I'll explain each and every term now. So consider this as your, one second. Consider this is your black box. Whatever going inside this black box, there is something that is going, there is something that is coming out, and it's not necessary how if X amount of value you are putting inside. It's not always necessary that only X will come out. Maybe whatever will come out, it will be more than X. It may be less than X. So if it is more or less than X, there will be something which is inside. This term is called as accumulation. Whatever is storing inside, this varies with the time. If you consider a steady state, if any time it is given in a question, consider a steady state. Steady state means time.
Okay, ma'am.
Parameters not varying with time. If any time you see a steady state is given, that means you have to take this term to 0. If nothing is varies with time, then this accumulation term is not there. Then there is only in right hand side of the equation.
Okay.
Okay. So then we comes with this. Now you told me that since this is the demo class, I have to. I'm not prepared with the flows of to the slit. I have to prepare with, because this is the demo class. So I'll give you introduction about transfer phenomena so that you can understand how I am explaining. So it's for your understanding that can you understand my teaching process or not. So moving towards fluid mechanics, heat transfer and mass transfer. There is one law. Do you remember what are these laws? Like this, all the concepts. If, okay, fine. I'll give you a revision for it. Heat transfer. Coming towards the heat transfer. Heat transfer is given by the Fourier's law. Do you remember what are the modes of heat transfer?
Yes, ma'am.
What are those?
Convection and radiation and conduction.
Okay. There are the laws for each and every these three modes, right? But these three modes we are not needed right now. The main law which heat transfer described is a Fourier's law. And if you remember what is Fourier's law, have you heard something like this? Okay, I'll tell you what you have seen. You have seen might be something like, is it? Have you seen something like this?
Yes, ma'am.
This is called a Fourier's law. In this delta T is replaced by dt by dx. Why? Because in our heat transfer subject, we consider all the things which are doing are only one directional. This is three-dimensional phenomena, x, y, z. So in our heat transfer, what we assume, everything is only varying in x direction, and there is no consideration of y and z direction. But when you comes to the transport phenomena, this is not the same thing. Now, this is why this delta t is written. It is a gradient which can vary in any direction, either x, either y, either z. Earlier we assume it should be only dt by dx, that only in x direction, but now you have to write like this. Any person asks you what is a Fourier law, you should write like this. What is Q? Q is rate of heat transfer. Rate of heat transfer is directly proportional to the temperature gradient. Temperature gradient can be in any direction, not necessarily only in x direction. When you comes toward the transport phenomena subject, you are considering a generalized system. And any generalized system has a 3 directions, x, y, z. Yes, there are more forms, latest form which we consider in 4D, but this is not part of your subject. Here Q is rate of heat transfer, K is conductivity. Right now conductivity K is C. I'll take another color. This conductivity K is outside this gradient. There is one reason why it is outside. That reason is we assume conductivity is constant. It is not a function of temperature, or it is not a function of space. What do you mean by it is a function of space? If this is an iron slab, consider this as an iron slab. What do you mean by constant at a space? Constant at a space means if this is 0 to x, 0 to y. Constant at a space means here, 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 everywhere it is the same. That's why it is outside of gradient term. If it is varying with x, suppose here at 0.5x it is something different, at 1x it is something different, at 1x, if this is different, then you have to consider this conductivity inside the gradient term. Then you can do it like minus of delta k dot t. This is a dot product. Gradient, dot product of the gradient. Now you tell me one thing, why it is a negative? I'll tell you. It's very basic reason. Have you ever seen a cold substance is getting hot without any external energy? No.
No, ma'am.
Right. But have you ever seen any hot substance is getting cold?
No, ma'am.
Yeah, hot system getting cold you have seen, right? See, if there is a hot iron rod kept open in the environment, it will get cool after some time, right?
Yes, ma'am.
But if there is a cold iron rod kept in environment, will it get hot after some time?
No, ma'am.
Why? This is because of thermodynamics second law. Heat transfer takes place only from hot temperature to cold temperature.
Yes, ma'am.
So if it is taking from a higher temperature to a lower temperature, T1, T2, T1 is higher temperature, T2 is lower temperature. How you calculate delta T? Delta T you will calculate final minus initial. But final is lower than the initial. So this quantity will be negative because this T2 is a small number, T1 is the greater number. So eliminate that negative sign. We consider negative in the law. That's so that overall Q become positive. Okay.
Okay, ma'am.
Do you remember the unit of this equation? One more thing you should remember when you are solving any transport phenomena question. There are equations. You are gonna come across so many equations. Every equation has an LHS and RHS. Suppose RHS has term A plus B. Two terms can be added only and only if they have same unit. Otherwise, they can't be added. And then LHS should have a same unit as RHS. Otherwise, you can't use this equal sign. So here the units delta T units of delta T are, this is temperature unit is Kelvin, X, Y, Z, anything. Direction unit is in meter. Direction means distance. Distance is in meter. Unit of conductivity unit is in watt per meter Kelvin. This is the standard unit. You should remember it. I'll write here. Conductivity unit is. So I'll write Kelvin little different for your understanding. Watt per meter Kelvin. What happened? Kelvin cancelled. per meter square?
Yes, ma'am.
And this is heat transfer rate, heat flux. And unit of heat flux is also watt per meter square. What do you mean by flux? Flux means rate of heat transfer divided by area. Right hand side is equal to left hand side? Yes.
Yes, ma'am.
Yes. This is a basic. This is a basic. Any time in transport phenomena, you came across the heat transfer. All these equations. I told you one standard equation. This is extremely important equation. You should. This is the base of complete transport phenomena. You have to incorporate heat transfer, mass transfer, and fluid mechanics into it. Let's move towards the fluid mechanics part, which is for your interest. You have a test on it. Which is the law which we use in fluid mechanics? Do you know? It is Newton's law of viscosity. Newton's law of viscosity. What is it, the law? This law gives us shear stress is directly proportional equal to concentration gradient. I'll write down. By the time you think about Newtonian and what are the Newtonian and not Newtonian? You told that it is gonna come into your syllabus, right? Instead of concentration, we can write in the better terms like how do you write a shear stress? Shear stress is written as a tau. To remove this proportionality sign, we need some constant. Again, dv by dx is considered only if it is a one directional. Otherwise, we have to consider it as generalized. What is this mu? This is as a proportionality constant considered as a viscosity. The unit of viscosity is Pascal second. And definition of viscosity is how it is the consideration of the flow motion of any fluid. So you tell me, you have a water and oil. If you have one glass of water and you have one glass of oil, so you want to pour that. Someone told me to pour the glass of water to the floor. Which fluid is easy to pour on the fluid? If you start pouring the both, suppose this is the water, oil, this is water, and you want to pour it. Which one will be poured fast to the floor? This is the floor. And which one will take time? You just imagine you have in one hand you have a coconut oil bottle and one hand you have your water bottle. Which is fast to drop?
Water will flow faster than.
Yes, definitely. Water will flow faster than it, because water is not as thick as oil, right?
Yes.
Another example. Now it's a winter season and started everywhere. So you have your coconut water. You kept the coconut water bottle and your drinking water bottle on the same table. Coconut water will automatically get freeze as the winter will increase. water will not get freeze. Water will only get cold. It will not get freeze. Why? Because water has a less viscosity as compared to the coconut oil. When you can you mix the coconut oil in water? Any oil in water you can't mix.
Yes.
Oil, this if you pour the water and oil will be always, because oil has a less density. So is there any relation between viscosity and density?
Yes, ma'am.
Yeah, there is a relation, but there is no any standard relation. What is this dv by dx? dv by dx is basically a velocity gradient in the direction of movement of the flow, in which the force is acting. This is shear stress. Stress means force upon area. So now we move towards one standard diagram which explains this formula. Then we'll consider the cases of depend on viscosity, which is Newtonian and non-Newtonian. Do you remember? Have you seen this kind of? This is y direction. This is x direction. Suppose your fluid is moving. Suppose your fluid is moving. Before this, you consider this example. This is a plate, and you're flowing. Your water is flowing like this. This considers a boundary layer. This is a standard phenomena in fluid mechanics. This is called a boundary layer. What we assume that at this level, the velocity is equal to the velocity of plate. If your plate, whatever your plate, your pipe, it's steady state, it's not moving, then the velocity at this point, which is very connected point between the plate and water, at this point velocity is 0. Velocity is basically equal to the plate. That's why it starts from here. At this point, velocity is 0. And if this is a total pipe, you consider this is a pipe. This is the center of pipe. Velocity is always maximum at the center of pipe. This boundary layer will be same. This is called as velocity profile in the pipe. Can you imagine velocity is 0 at the ends of the pipe and velocity in between pipe? Any fluid move. So velocity is varying. Velocity is not. If this is the radius of the pipe, velocity is varying with the radius. This C. The radius is always start if this is the pipe entrance. You have to see this one. This is center. This is radius. Imagine this is the side view of the pipe. So this is the pipe in 3D. We are imagining this is side view. This is front view. So, and this is 0. This is R. So as we are moving towards the edges of the pipe, velocity is decreasing, and at the center of the pipe, velocity is maximum. So the velocity is varying with the radius. That's why we have to consider the velocity gradient in the law. Right. In the heat transfer, what we consider? We consider a temperature difference as a driving force. Now in the fluid mechanics, we have to consider a change in velocity as a because it's a fluid. It's moving from one position to another position. So if you see, you have to run from A to B. Will you start from this point? At starting, you will run with the speed, some slow speed, and then once your warm up is done, you will run very fast. You will run extremely fast. You are running extremely fast. But as you know your destination is arrived, you will again slow down your speed. That means your speed is changing with the from transporting one place to another place. Your speed is changing. Similarly, the speed of the fluid is changing from one place to another place. In this fluid mechanics, that's why we have to consider a velocity gradient. And this viscosity is a proportionality constant. So now we comes toward the types of fluids. These types of fluids are considered based on this viscosity. Types of fluids are considered